All right, everyone. At this point, homework should be in, and you should all have a handout. So here's what we're going to do. I'm going to start by reviewing area, and we're going to use the ideas that we're developing and our review of area for volume. So if you notice on your handout, the first question says, here's a picture of a rectangular region whose length is growing. All right, here's a hint. This, oops, see this blank right here? Rate is one of the words. All right, rate is one of the words in there. Yes? Yeah. Anyone last chance for homework?
We need one more worksheet.
Oh, can you have the extra? Are the extra at the back? Thank you, I appreciate that. And so you have your worksheet, and I'm going to put up here this animation, and what I want you guys to do is to fill in all 4 of these blanks, all right? Oh, sorry, 3 of these blanks. Here's a blank, it involves the word rate. Here's something, how can you write that? And then a very specific meaning. It cannot be something like how fast it grows, right? How fast doesn't tell me why the number's 4 instead of 7, or -3 instead of -1. So I want you guys to use the animation. I'm going to be walking around and be working in, let's see. So here's what I want you to do. You guys are all on my recitation. Turn your desks and bodies towards each other to create groups of 3 and 4, and then try to answer that first question. Oh.
Well, maybe this is for you to square.
It's up on
Yeah, I'm not sure if it's very
Which button? White press to make it go forward.
Turn this in.
Homework. All right, and then go ahead and there are some extra handouts at the back.
Oh, really?
Sorry.
Everyone, y equals 4 defines the top of that rectangle. We need that, and I thought it would show up.
Oh.
Actual worksheet. I am.
Yeah, because it's.
I accept.
Base turning is whether it's So the input anything doesn't necessarily have to be just one. It could be a division, right?
Yes,
So
but it is less quantity. That tells you.
right and left and top down. Right back.
I'm already seeing some good answers, so I'm going to put some of them up. What kind of rate is it? It is a constant rate of change. All right, so you should have constant rate of change. Let me put that in red. And of what? 4. Wonderful. I'm not going to put the units up, but let's talk about them. What are the units of this? So if I'm running, it's like meters per second, right? So it's how much the area is changing, which is units squared. With respect to length, you have units of units. So what is it? It's unit squared per unit, right? For a little unit change in length, it tells us about the unit squared change in area. And I also I'm seeing some great beginnings for any change in length. How can you finish that off? I'm seeing a lot of people talk about a change in length, which is great. I'm not seeing them talking about a change in volume. Then they just kind of say something about the rate. But you can't define the rate as 4 by saying the rate's 4, right? That's like a circular argument. So you have to describe this without using the word rate here, because you can't define rate using rate. I can't define ostrich by saying, oh, it looks like an ostrich. Like, that doesn't help anyone who doesn't know an ostrich, right? All right, so try to finish that last line, and then we'll add it up. Give it another 30 seconds.
The verbiage changes or something, rectangle grows in area.
I guess it is a change area or
That's what the back page will. But if we were talking about the quantity that's being represented, we have to say, right? Because it's talking about the range.
So we're not saying this. They taught us how to we use the word derivative or integral. He would give a graph, he would do a line thing, he tried to sum things up.
That's how they define it.
Is there something? So that was like up to March, spring break. Spring break.
Why does it say 4.1? I didn't realize until after I did it. When you put 1, 2, 3, 4, so
He even did
one,
I
I
think
put
he did
one,
one
three,
has functions and then he had
so it's
our operation.
I was at home, and then I wrote the function 2.
Are we videotaping? Yes, we are. All right. Here is what you should have. Now, it doesn't have to be the exact words, but you do need to have this idea that we can't define rate using rate. So instead, we're going to define rate as, let's compare as my little animation runs, a little bit of change in the, go forward, a little bit of change in the length, like from here to here, so the little change in length is there. How much extra area do I have as it increased that length? 4 times as much as that little change in length, okay? And it is also exact. So now we have a different situation where now it is not a rectangle. So I want you guys to think about, how is the question going to change? How does the, what do the meanings of the rate, how do they change now that I have something that's not a plain cylinder? So I want you guys to answer the same question, but now it is under this curve. And again, it's growing like that, and we're still doing area under that curve with respect to length. There are at least 3 changes you should make. Don't just copy your answers from the first ones. All right, discussing your group still. the change now?
So it's a increase in like x or an increase in f(x) dx. It's different. Yes. Like every increase in length where x is an increase in f(x).
I'm gonna show you this. I'll just make sure, are there at least 3 differences between the answers the first one and the second one?
Right now. Yeah.
Is the constant rate of change? Nope, so all we can say is it is growing at a rate of change. Alright, what is the rate of change? Now we're talking about f of x, so is it f of x or is it the r sub f of x? Okay, poor man's clicker. After I say 3, you all yell either f of x or r sub f of x, and that way I can just kind of see if we're all in agreement or not. 1, you have to make up your mind. Which one's it going to be? Alright, 1, 2, 3. Alright, I got many more f of x's, which is correct, right? Because look, if this is f of x, we don't want to take the rate of that. How is the area going to increase? It's like little bits of rectangles with the height of f of x, right? Not a height that is the derivative of that, just that height. Wonderful. So it is of f of x. Alright, now, can I have a volunteer for how we need to explain exactly what it means to have a rate of change of f of x and how that changes from the more simple idea of constant rate of change? Who's going to be brave? Yes.
For any change in x, the change in area is represented by f of x dx.
All right. For any change in what again? X, the length, right? But we can also say, I'm going to put length and then parentheses x. The change in area is f of x times as large as the change in x. All right. There's something wrong about that. I had a hand in the back. Did that person have something a little different that they can modify? Yeah?
I was going to add something else to that the area is only like, it's not like, as I said, any unit x is like as long as, we should be able to add it as long as x is sufficiently small.
Yep. Because watch this. So I don't have an animation. No, if I have a rectangle, it's always 4 times the change in x, no matter how long I make that change in x, right? Now, I always have to use my head. What if I have this curve? All right. If I have a large change in x, you guys see how it's kind of trapezoidal now, right? I can't just do the rate times dx because the rate f of x times the change in dx would only give me this. But really, we should be getting a little more accumulation of area by then. So we need to change this to a tiny. Let's see, let's make this in red. For a tiny change in, and what's the other thing now? Even when it's tiny, what's different from what we wrote for the first one? It's not exact, right? It's still, when it gets smaller, now look at how much extra, let's do it over here. If it's small, then it's really close because look how much off it is. A really tiny amount. But it's still going to be off, so we need to write approximately. Or I'm going to write close to. Is close to. And what if it wasn't close enough? What if I'm like, this is still way off? What would I do? Yep. The smaller the change in x, the better the approximation. When x is essentially 0, approximation is pretty exact. Right? There are the differences. Yeah. So don't just memorize those, but make sure that those become really clear in your head, because now today we are moving on to volume. A constant rate and change, you cannot say how fast or it's the rate. It is how many times as large the change in the output is than the change in the input. A rate of change is approximately how many times as large the output is than the change in the input for a tiny change, and you get tinier and tinier changes to make it more and more exact. So now we're going to move on to volume. So we're going to define this phrase right cylinders in a very specific way. So in the book we have examples of right cylinders right here. And here, here's the definition. If you notice, all of these they're very strange shapes, right? They're not the cylinder we think about in elementary school where it's only a round base. But if you notice, each one of these have a top and a bottom. Let me start the animation so we can look at them. The top and the bottom are going to be parallel to each other, and then the sides are going to be straight up and down and therefore perpendicular to the top and bottom. Okay? So this is a cylinder. Even though it has a funky base, it still has these two top and bottoms. Oh, he animated them in a weird order. Okay. Oh no, it was right. The top and the bottom are parallel. The sides are straight up and down and so perpendicular to the top and bottom. They can also have holes in them. So just to make sure everyone understands, because last semester we were getting pretty far in and people are like, I don't know why he's talking about cylinders when we're having funky shapes. Defining all of these as right cylinders. Please draw. Really fast, you get like 2 minutes to do it. 3 right cylinders with different funky bases, and give at least one of them a hole in the base. So the hole is just like a core of water tree, right? Top and bottom are parallel. Sides are perpendicular to the top and bottom. And as you're doing that, send an eye over to your people next to you in your group to make sure that they are also getting it. It can have holes, it can have weird bases. It just means parallel top to bottom, straight up and down sides. Is a cube a right cylinder? Yeah. Whichever side you think is the top and bottom, they're parallel to the cube, right? So the cube, the other 4 sides are going to be straight up and down, perpendicular to them. A cube is one of the things that you draw. And like 30 more seconds, and we're just making sure, put an eye over the person next to you and make sure they also understand all the different things a right cylinder could be. As long as the bases are parallel. I should say all right. No matter how many cylinders you've drawn at this point, we're good. I saw everyone keeping an eye on everyone else to make sure they understand this right cylinder. On the back, I have for you guys an example of this cylinder, all right? So if you notice, it is 2 meters high, and it's got a hole cut in the middle, so the inner radius is 2.5 meters, and the outer radius is 3 meters. So I have a video from the book there's two ways I could make this guy grow. I could leave the radius alone and I could increase the height, right? Or I could leave the height alone but increase the outer radius. Either radius I could increase. So my question for you is, you have the original volume. You know how to find the original volume because I gave you all the measurements, right? So what if the height increases by 1 meter? So for part A, the radius isn't changing at all. The height's increasing by 1 meter. And then for part B, what if we leave the height alone, but the outer radius increases by 1 meter? What are the changes in volume? So just for this, use your calculator, your laptop, your phone. I want, after all your work, an actual number for A and B. An actual number for A and B.
The roundabout is parallel on all sides are perfect.
Write down all your work, and then put it into the calculator at the end. Oh, yes, sorry. Guys, what's the volume of something where it has the same base that's just dragged up? It's going to be, yeah, so it's going to be, a solid cylinder would be pi r squared and then times h, right? So now you guys figure out what a cylinder with the middle cut out.
So wait, what is it? Oh.
Your area of the base, which is pi r squared times pi. Now in this case, you've got an outer cylinder, which is positive, and an inner cylinder, which is negative. So you've got the positive minus the negative.
What's the negative?
Would be 2 point, it'd be
I did not calculate this.
2.5 squared times the height.
So, what is the change in volume?
So this is a new. So you have the height of 3 versus the height of 2. So you do the large cylinder minus the little cylinder inside, because we're only including that. That's why I did. And then she wants to count back. No, there's no variable. I'll just like you're gonna have one answer. There.
So it looks like what it is.
That would, well, no. So that's with both height of 3. Yes, that's your final. So you increase the height by 1, but now you've got to subtract when your height was 2. Because you're trying to find the change in volume.
Make sure, what's the initial volume for both problems? For people getting you should get about this. If you're getting around this, then you know you got your initial volume correctly.
Height increases by 1 meter. So if you have the current original one, then you have to calculate the original meters of height take to that.
Because that's your, yes, your inner ring. So you can think about this as a solid cylinder, and then you cut out a hole from it. So you take your volume of your solid cylinder and subtract the volume of the inner cylinder, the hole that you drilled through it.
This eyeball, but that looking at
Yeah, she gave you an hour of farm meeting. About, yeah, 8.68.
Yeah, 8.6. I got 8.6.
Okay, yeah.
Did you use pi or?
I use pi.
Okay. Yeah, I used the pi.
Yep.
I'm not putting the work up on purpose because that's for your group. But if you got that, then you got the correct answer for A, and now do B. 2.5 to 3.
You've got cons height of 2. 1.64. Final one's going to have the outer radius or your initial.
It's still gonna stay the same.
Yeah.
So we'll just change it. So that stays the same.
Anyone have B yet?
Yeah.
43.9 points.
43.98 approximately. So I took the ball.
Okay, let's take only about 1, maybe 2 minutes more to finish. Make sure that you can get those same answers.
Area of the
And
big
not just
circle
by copying
minus
them
area
down.
of the small circle. Yeah, that's when I did all those calculations. You gotta be careful with parentheses if you put it all in one section.
Oh, yeah. So this way, 5 plus 5 pi is around 17.278. Yeah, you keep it in terms of pi, which
Akina, I'm pretty much equal. I got
For B.
So if you want, just multiply
So
it with
basically what I'm
0.4 to
getting
make
here
sure that you have
is,
it.
we're talking about a change between this cylinder if we were to take this 3 and change it to a 4. So
That's
we've
only
got
eight, right?
the area, basically what I'm doing is area of this disc times the height.
Anyone else?
So
We're gonna move on.
our final point is 4 as a large diameter and 2.5 as the middle. So area of the big circle minus the small circle times the height, and then go back to the original of 3. So the thing we're changing here is just that volume. Before we were changing this one. Yeah. So yeah, when we were changing this one, I was changing my in this case, I'm changing my hours. Exactly. 4 significant reasons. I've had sick trouble in my head for so long.
I completely never take it. So when it's like, I like to
I like sick things. Yeah, significant things.
I like having like 4 decimal places after. I mean, I know how to do sick things, but I mean, if you put more, then you won't choose the right answer anyway, because you're gonna have like.
Yes, but if you put more of those last 6 digits.
Well, no, I don't really.
And everyone, right now, start thinking about C. I don't mean like how different they are. What's something we need to realize about the rate of changes, because those numbers are what they are. Deliberately vague, open-ended question. Discuss. Go. What do you think?
So the rate of change is
Here.
Yes. Yeah.
Dave, question. Which makes more sense. That would. Which, 43, I keep getting confused.
Do you have still inside radius is 2.5, outside's 4 now?
Do the outside.
That makes sense.
That's going to be 16 minus 2.5.
Yes, square term. Square term.
Times 5, and then all times 2. I remember that.
Outer radius.
Area of the base.
Did you get
That's
that?
why you got your base here.
Oh, they're the
Yes. Each area is higher. So now you've got a big circle minus a small circle. I would think
Hi. All right, everyone. Okay. It's one of those questions that are deliberately open-ended because if I ask you the exact question, the answer would be obvious. So who can just say something about the rate of change of volume with respect to height and the rate of change of volume with respect to radius for any cylinder?
With respect to height, the rate of change is going to be constant.
Okay. And with respect to...
With respect to radius, it's not going to be
Wow, he even jumped ahead to what we're going to do next. But it does make sense, right? If it just goes up like that, do you see how it's always going to kind of go up by the same amount if I increase one? If I increase one another amount, it's going to go up by 8.6 again. Because it's just like another little chunk of the thing you put on there, right? But if I increase the radius by 1, do you see how now the extra width that I put on is going to be even bigger because it's like going around a bigger circle, like an extra radius 1 wrapped around like that? Perfect. All right. Any other comments that are even simpler than that? What can we say about rate of change of volume with respect to height versus rate of change of volume with respect to radius? So he jumped ahead and gave me an even better answer. They're not the same, right? They're not going to be the same. The rate of change as you increase the radius is going to act very differently than the rate of change as you start thickening. Sorry, the rate of change as you drag the height up. It's going to be very different than the rate of change as you make the radius thicker.
If you like have them change the same amount, like if the height changes 1 and the radius changes, or like 2, I guess, then the rate of change with respect to the radius would be larger because you have to square it.
Another great point. It's because of the fact that that rate is squared, right? And so it increases at a faster, that's going to increase at a quadratic rate, whereas the height is going to increase at a linear rate. Okay, 3 great answers. I was just looking for different, but you guys are way ahead of me. So now, why don't we actually think about how are we going to actually quantify that? So I don't have any numbers here. So instead of numbers for this one, you're going to actually just put in names of quantities, right? Instead of 4 or f of x. So really ask yourself, and when you do that, look at this definition. What does the definition of a constant rate of change or rate of change mean for a little change in the input, an independent variable? The change in the dependent variable is the value of the rate of change times its big. So then what do you think you can do to fill in these answers for this one? Growing with respect to height. Okay, make sure that you get that one before you go on to radius, because I started with the easier one. How can you fill in those 3 blanks? Go. Discuss. You have to be creative. It's not something I've ever told you. And there's no exact value.
Because in this case, you always have the same area of your base, right?
So sorry guys, I'm hearing something, so I want to clarify. This is no longer the 2.5 to 3 radius and the 2 height. This is now representing any cylinder ever. Okay? For any cylinder ever. All / any. There. So you're going to have to be a little more general.
Always changes area of space, yeah. Which D or DH, delta H. Right of the area of space. Because right equals to the area of space. about it this way, when you talk about volume of a cylinder, you've got the area, the base times the height. So for every increase in height, you're multiplying by, well, for every increase in height, you're multiplying the area of the base figure times the height. So you've got height rate change equal to the area of the base figure. And so for every change in height, there's an increase in volume by base area of dH.
Yeah. Well, it's not always pi r squared, it's just the area of your base. Yeah. It's for any cylinder. So yeah, you have to it's the area of the base. So the volume is what's changing. Yeah. So the area of the base stays the same.
There was a word.
You're reading very much.
Okay. Do you guys all agree it was a constant rate of change? In fact, I think we have a student already described that before we started. Who wants to take a guess? In fact, let me do this. I'm going to go ahead and fill in what we mean by it. We mean that, come on, behave. We mean that for any change in height, the change in volume is going to be blank times as large as change in height. So imagine any cylinder. It could have a hole, it could not have a hole. It could be round, it could have a funky base. But as the height increases, you're going to have a little change in height. What would you do with that change in height to get the change in volume? One different volunteer this time. Come on. Get the same people over and over. Be brave. And groups. All right, go ahead.
Multiply by pi r squared?
Okay, tell me, we can't say pi r squared because remember, it's for any cylinder ever. But tell me how you thought of pi r squared.
Well, just because that ends up being the constant, or as the height is changing, that pi r squared is remaining the same.
It's not going to be true if I have a funky base like this, though,
Oh,
right? However, he's on the right track. I think he put a value for a question that's too general. Yes.
Just do the surface area.
All right, we got surface area. So do you think you calculate the surface area, got the top, the bottom, wrap around the sides, and it's always going to be, take that little change in height, multiply it by the surface area, you're going to get the change in volume? I have some people that disagree. Yes?
Would it just be the base or the change? Yeah, the area of the
So again, I saw area, then we got surface. We're building up to it, but it can't be the surface area of the whole 3D object, right? It's just,
area of the base.
it's just the bottom or the top, same thing, right?
So
You take
area of
that.
the base.
Yep. Area of base. Area of base. You can also call it the surface area of the base, but a base is two-dimensional, so you don't need to specify surface area. It's going to be area of base times as large. So last semester, when we piloted this version of Calc 2, we had people that were really struggling with this after a while. And I think it's because you have a constant rate of change, and if you just think of rate as how fast something increases, it's really weird that a rate is the surface area of a base. But if you have the meaning that it is always the change in volume is going to be blank times as large as the change in height, then of course, if you have a little additional chunk, so I'm going to draw a little additional chunk on here, how much is this change in volume? Well, I'm going to take the little extra height, so what should I call that? DH. I'm going to take DH, I'm going to multiply it by the base, right? And that's going to give me the little change in volume. Wonderful. All right, what's a little bit harder is when it grows. Oops. Everyone, I did this handout in a hurry. So everyone, the last thing, please cross out height and write radius. Otherwise, it's the same question twice. With respect to its radius, and here, you know how hard it is to find a beer cozy at 9 in the morning? It's very hard. All right, here's my volume. Okay, there's no dents. It's just like flat top and bottom. Here's my initial volume. Here's my little change in volume to get my final volume. I should have drunk more by now. Because the radius increased this much, right? So how can you figure out what the change in volume is? How can you fill out these three blanks? Initial volume plus change in volume gives you final volume. How do you calculate the volume of my beer cozy? Take a few minutes. It's a crazy thing that you have to do that. You haven't told them.
Because now we're talking about, and here we are going to dimensions. Now if it's just about the line that I have, how can we that circle, compare this circle, this circle, this circle, whatever, it's always changing. It's not going to
Instead of just like up and down, like here's my cylinder.
Of course, if we were, well, I'll talk about them later because I just feel like it's confusing.
You're going to have to be creative. Draw pictures for yourself. You have to discover something that we have not yet told you.
It's not just the height. The varying rate
Is this? Probably.
original
It's a little more complicated. It's not going to be one word in that line, but it is doable.
Solar volume grows at a rate.
Do you know the radius? Because it's from wherever we started. All right, hint. Everyone, hint up here. So I have my final volume. If I just look at my change in volume, then it's this cylinder thing, right? But when you have the number one rule in math is you don't know how, or science, you don't know something, you change what you don't know into what you do know. I don't know how to deal with this, but I do know. That was real fast. I do know that I could cut it and flatten it out. Okay? And now it is a flat rectangle, but also with some depth. Okay? Now, it's not exact because do you see how, imagine unwrapping it like the edges are slightly like flared, just how this was a little bit flared. But we're only going to talk about a tiny change, right? So can you figure out the volume of this now that I've uncurled it? What is the volume of this? You don't know how much the original radius is. It's just R. How much is this? How much volume? Draw a picture. Draw a picture and label all three dimensions of this. Now a cylinder. Does it
I guess if you make so there, oh yeah, there's no
changing circumference, time.
yeah.
No, not changing. Yeah, we're doing 2 pi r. Yeah, we're still dividing here.
Yeah, we just need to.
How do you calculate that little bit of change in volume?
You can calculate dB by taking the circumference of 2 pi r times the height times
Formula right there.
dr.
Just rolling out.
Formula for dV. You know what a rectangular solid is, right?
So your line is there, the circumference is down the basically dr, your change in radius, and your height is calculated. So dV would be 2 pi r times height times dr. Because that's 2 pi r is the circumference for diameter pi.
Okay, that's what I was thinking there.
2 pi r diameter pi same thing. I just like radius.
It absolutely is. Like even if I have something all weird, I can still look around it, and every time I see a radius, I can just, I can even, the easiest thing to do is I can slice up like a pie and then just do it individually, so it still works as a radius. It's just that this guy has differing radiuses as I go around, but they'll still work. Right?
Well, one of the ways we were talking about, and let's say it was a heart-shaped cylinder, right? Now that one that's growing,
Which dr is
slice it up and stretch it out like
2
you
pi
did
r
there,
dr.
and that becomes the height.
Which part becomes the height?
The part that's changing,
2 pi r h.
becomes the height.
Well, the height of the height is
That's the part that's changing, because remember the height stays constant, the radius.
that's surface area
All right,
times
but that's
dr.
that part that you peel off, and then you lay it flat.
Height, yeah, so that's like, so it's always
No, ours.
It is.
yeah.
But we wouldn't use pH in this constant, because how much is it? So we're almost at time, so we're gonna go over it. Everyone. Can someone give me one of the 3 dimensions? Come on, oops. Right. Right there.
Well,
Give me one of the dimensions.
2 pi r or 2 pi
Alright,
r.
and which is 2 pi r?
That's basically your circumference.
Yep. This circumference of the extra one got unrolled into all of this, right? So this is 2 pi r. It's kind of like the beginning r, okay? So you can think of it as the beginning r, but I'm not going to put a thing on here because it's not actually a number I know. As I make it bigger and bigger, the beginning r changes, right? So you see how the initial r is no longer a constant, even the initial r is changing as it gets bigger? If you've got some r, then change a little more. Now I've got a different r that changes a little more. Great. Alright, a second dimension. Alright, and where's h? Yeah, it's still the same height as the can in the first place, right? Alright, that is h. Alright. And then we've got this. This is the amount that it increased in what? What increased?
The radius.
Radius. Alright, so then what should I call it? Wonderful. What's my change in volume? What's my additional volume for my beer cozy?
2 pi r drh.
2 pi r h. Yeah. Questions about that one? Okay, so now, how could I fill in this statement that says, for a tiny change in radius, the change in volume is blah times as large as the change in radius. What would I fill in there that is true?
But if you weren't using the numbers, it would just be pi r, 2 pi r.
We just want to fill in, oops, sorry. The change in volume is something times the change in radius, right? Well, if we have this, what goes in that blank? It's that one, right? It is 2 pi r h. Your homework for the weekend, Mark might assign you some else, but also 2 times pi times r times h. Your homework is to go over this again and again until it really makes sense. If you have this, everything else can fall in line. But otherwise, Mark comes back Wednesday and Friday, and you start doing more and you don't have this solid, you're going to have to be like, what is he talking about? Alright? So, my homework for you is to go over this until you understand it. I'm going to stay. If you have questions, I know that this last one's a little hard. You have to imagine unrolling it and using this meaning of how many times is big to even jar. That is the definition of a rate. Have a wonderful 3-day weekend. I have no questions. Come on up.